I'm trying to build up this idea of computer science from scratch. It's not a rigorous derivation. It's very highly mathematical, though. But it's not rigorous in the sense that I can't do it from first principles alone. But my background tends to be, my undergrad was in physics and neurobiology and English, and then my master's was in business and physics, and then my PhD was in computer science. So I build upon a lot of the stuff that I have that I started working on. And one of the core ideas that I found is that computer science, for the way that I build it up in the text as well, is sort of a superset of physics. If you think of like math, for some reason, nature tends to speak this odd language of math. We don't know why. You know, there's the unreasonableness of why math describes nature, but nature tends to speak math. And so all of the stuff, if you're a reductionist, you might look at stuff in physics, and you see that all of the things in physics, all of the equations in physics, it turns out, are computable functions. So what exactly does that mean? This is what sort of mathematicians around the turn of the last century started to struggle with. And so people like Turing and von Neumann started to answer this question. And they started to talk about what it means to be able to compute the answer to a function. And so this led to the idea of computable functions, and Turing machines or algorithms were a way to sort of categorize that. And so it turns out that every single function in physics is computable. Every single thing in physics is computable. And this nascent science that started to arise, computer science, which started to deal with figuring out what things are, what functions are computable and what are not, started to sort of serve as a boundary between what's physically known to be realizable, and what's just weird math stuff. Right. So there's a lot of stuff in math. Mathematicians are much smarter than me, so I don't understand all their math, but we do understand those mathematical ideas that we can apply to physics. And computer science sort of sits at the boundary and tells you which functions in math are computable, so that they either are already applicable to nature and physical reality, or might in the future be so.